Hello, statistics student. This video is for chapter 2.3 and 2.4. We're looking at how to determine if a number is an outlier in the data set. Instead of using just a histogram, look at if there is bars or there is one number far away from the rest. We use a more standardized mathematical ways to determine if something is an outlier. The way to do it is based on something called the interquartile range, IQR. And in order to introduce IQR, we have to talk about percentiles. So ultimately, this two section is at uh, you know giving you a way or showing you a way where we can determine something is an outlier. It's an agreed upon way. So you don't have to determine an outlier subjectively, saying that, oh, that is too low or that's too high. So the basic concept is look at data or divide data in sessions very granularly as in percentiles. So what are percentiles? So if you have a lot of data and if I kind of use a number line to line them up, okay, so they are like this. I don't stack them up. So we arrange them one after the other. So sometimes one data cluster around, sometimes they evenly distribute. So anyway, just line them up. Then we can cut them into groups, right? So this is the first one, the lowest lowest 1%, lowest 2%. Like you cut them up like lowest 2%. Oh, the lowest 3% is this number like that, and we call them percentile. So this would be P1, P2, P3. What does each percentiles mean? P1 means 1% of the data is lower than this number. P2 means 2% of the data is lower than this particular number. So it is a marking. So if I have P3 equal to 7, say for example, I would say of all the number, 3% is less than this number 7. So a percentile tells you, oh, how many percent is less than that number. So, and we call them P sub 1, P sub 2, P sub 99. So the last set would be 99%, this number. If this is P99, 99% of data are less than this number. Okay, and here I have another one that I write down. If x is a value like 5 or 22 or 1000 is the 90th percentile cutoff, that means 90% of all data are less than, okay, below this value, below this x value. So if we are talking about grade, if you are at the 90 percentiles, you are better than 90% of the people, or 90% of the grades is below yours. So it's good to have high percentile. Now, if you're talking about running, okay, so you want running time, you want to have as short a time as possible. Then a high percentile is not very good. You want it to be in the low percentiles because um, your number is less than, or 1% of people is less than you. So that 1% of people is faster than you or something, right? So but remember, percentile is not the same as percentage. And for percentile, it indicates the percentage that is less than that number. It's always about less than. Okay, that's just things to remember. For example, if a student has a score of 78, this is just a raw score. Maybe it's out of 90, maybe it's out of 100. We don't know. This is the points. Maybe it's even out of 200 or something. Or maybe it's out of 80, then there's a very good score. So in order to know how good it is, somehow the teacher say you are at the 82 percentile. What does it mean? It means interpret the meaning of 82 percentile. 82 percentile means you're quite good. You are your score of 78 is better than 82% of the people. Does that make sense? So it's about how many percent is less than your value. Oh, I should write it down. So I should say 82 percentile means the score 78 is better than, in terms of better than, that means higher than 82% of the class of all grades. in the class, right? So should a student be pleased? I think should be, right? Should be, because let it less than 80, about 82% of all students are below that person, right? Should be, because it is in the top 18%, right? So only 18% of people. So if you look at this marking, so this is the score of 78. So there is 82% of people. How do I know it's 82? Because it is 82 percentile. 82% of grades are below you. We don't know what they are. They are 70, they are 60 or whatever. And then there's 12% of people is above you. So it is, you should be quite pleased. Example 2, if a student score at top 10%. So now if you want to look at top 10%, that means this is your score. And top 10%, that means including your score, that constitute 10% of all the people. So what percentile would this be? If you're at the top, so top means you're high values. If you're top 10%, that means you're at the highest 10% of all the grades. That means you're better than 90%, right? You're better than, so 90% are less than you, are less than that score. Right? So that means what percentile would it mean? So the score is 90th percentile. So for percentile, there's no decimal, it's all whole number. You're either in the first, second, third, like that. Okay, whole number. Okay, so it is opposite of top. So, and then there's 3 percentiles that we're really interested knowing, because these 3 number determine how to identify a number as an outliers. So we're gradually developing the idea. So there's 3 percentile that we call them quartiles, because they divide number into 25% range. So the first 25%, so this would be the 25 percentile. Because it's 25, we call it Q1. And then this is another 25%. So totally this would be 50%. So that, of course, this is called a median. And sometimes we call it Q2. This is OR. And then we have the third, which is 75%. So this is another 25, another 25. So for this score, it is better than 75% of all the data. This is Q3, and that's the highest. We call it max. Okay, highest number. And this one we call it minimum number. Again, this is the top 25%. So Q1, Q2, Q3 basically divide the session into 4 quarters. So that's why we call it quartile. And this is actually percentile of 25. This is 25 percentile. This is the 50 percentile, and this is the 75th percentile. So Q1, Q1, Q2, Q3 are just another name for it. Okay. So if a score is at P25 or Q1, it separates the bottom 25% from the top 75. It's better than 25% of data. Second quartile is the middle. It separates the bottom and the top 50%. The third quartile separates the bottom 75% from the top 25%. So how do I find this 5 number? And actually this 5 number, including minimum, Q1, median, Q3, and maximum, is called 5 number summary. So these 5 numbers are called 5 number summary. And out of Q3 minus Q1, you can see if I separate everyone into quartiles, 2, 3, 4, like that. So the middle Q1 and Q3 would be the middle 50%, right? Middle 50%. Middle 50% of the data would be in this range, because I have 25 and then 25 bottom and 25 tops. So this is called the interquartile range, the middle 50%, and we call it IQR, interquartile range. Some calculator will calculate IQR. If they don't calculate IQR for you, you calculate yourself by subtracting Q3 minus Q1. It's a number that indicates the spread of the middle half of the middle 50% of the data. It's the difference between the third quartile and the first quartile. Okay, so just introduce something that you might have known. There is a plot called box plot. You might have learned it in middle school that show this 5 number. So you would draw a box using Q1 and Q3 and the median in the middle of the box. And then the two whisker expand from Q1 to the minimum and Q3 to the maximum. Okay, so this is not something that we are interested because it just show how Q1, Q2, Q3, how the 5 number separate. But it's nice to know that, oh, most of the day, there's a lot of data in the lowest 25% because it's really short. That means this constitutes 25% of data already, but it's quite short. And there's a big range here, or, in the middle 50%, that's the box. That's the interquartile range, right? That's how big the middle 50% is, IQR. So it's just a graphical representation of the 5 number. How to find the 5 number summary? There's 2 ways to do it. The easiest way is to use one variable statistic calculator. Another way, if you have the data in a table form, you can use statdisk to do it also. Okay, so I'm going to show you how to do it with one variable statistic calculator, which require all the data in comma form. So one easy way is to actually just copy the data by copy and paste it. Can I do that? I think I might need to close the comment maybe. It seems like it doesn't let me select anything. Okay. Let's see. How do I select this? Earlier I can do it, but now I cannot. Let me see. So I already closed this. Already closed the comment. So maybe I can say edit. Maybe if I do edit, it will let me copy and paste. Oh, yeah. Okay, so I think it's better. So I copy the data, copy it, and then what I'll do is I'll go to the browser and then search for this one variable. Oh, it's under LibreText. So LibreText one variable calculator, statistic calculator. You can also find this in Canvas in your calculator link. You see this one variable statistic calculator. You paste it in comma form, and you calculate. Okay, so the 5 number will be here, right? Okay, so don't include the mean. The mean is not the 5 numbers. 0, 20, 40, 60, 300. So 0, 20, 40, 60, 300. The IQR, of course, will be Q3. Oh, I calculated wrong. Q3 minus Q1 should be what? 40. I don't know why. So I'm gonna change it. Okay, so this one is wrong. So IQR is Q3 minus Q1 is equal to 60 minus 20 is 40. Okay. So that's how you do. I just want to make sure that yes, 20, 60. Right. So if a student exercise only 20 minutes, what can be concluded? 20 is what? 20 is in Q1. So right, 20 is equal to Q1. That means the students the exercise times 20 minutes or the students is higher than or better than 25% of all other students. Right? Because this is the exercise times. So there's 25% of students exercise less than 20 minutes. Yeah, so that's how you find the 5 number summary. So I'll continue to talk about what is the use of IQR to define outliers in the next video.